So I'm Impan Apaji. Let's start this video. Yes. Now, how binary search works. For a binary search to work, it is mandatory for a target array to be sorted. We shall learn the process of binary search with a pictorial example that the following is a sorted array, and let us assume that we need to search the location of value 31 using a binary search. Students, as you can see, we have a pictorial diagram here. So it's an array starting from 0 index to 9 index. So the memory location is 10, correct? So we have arranged all the numbers in ascending order. First, we shall determine half of the array by using this formula. So what is the formula? We have to divide the array into two. So it is called as binary array, and we have to go for searching. What is the formula used? Formula used is mid is equals to low plus high divided by 2. Or we can say mid is equal to low plus high minus low divided by 2, which is equals to 4. That means the fourth location is nothing but the mid value, which is 27. Okay. So what is the advantages of binary search is we are only traversing half part of the array, either the first half of the array or the second half of the array. Now we compare the value stored at location 4 with the value being searched is 31, correct? So we find the value at the location 4 is 27, so which is does not match. That means first we'll check the mid element, which is 27. Now our searching key element is 31. Obviously it will be greater than mid, so we are searching the right part of the array. So we change our low to mid is equal to low, mid plus 1. So low is equal to mid plus 1 and mid is equal to low plus high divided by 2. Now we can see is now we compare the value stored at location 7 with our target value is 31. Now we can see, students, we are searching for the number 27, correct? But our key value is 31. Obviously it is greater than 27. So it is the second part of the array. Our new mid is 7 now, correct? We compare the value stored at location 7. The target value is 31. Again, take a next part of the array. Again, divide the array into two halves. So mid value is 5, 6, 7, 8, and 9. The mid value is 7. 7 is the location. The value stored at location 7 is not a match, correct? So our value is 31. Obviously, it is less than 35. Rather, it is more than what we are looking for. So the value must be in the lower part of the location. Hence, we calculate the mid again. This time is 5. So in the midpoint, so we have a value which is 35. So we compare the value stored at location 5 with our target value. We found this is a perfect match, correct? So we conclude that the target value 31 is stored at location 5. So binary search halves the searchable items and thus reduces the count comparisons to be made to be very less numbers. So this is how we study the binary search, students. Yeah. Now let us see the pseudocode. Yeah. So A is a sorted array, N is the size of the array, X is the value to be searched. Lower bound is 1, upper bound is N. So what is the mid value is equals to midpoint is equals to lower bound plus upper bound minus lower bound divided by 2. So if A is midpoint is less than X, we search the lower bound, that is mid plus 1, midpoint plus 1. If A midpoint is greater than X, then we search set upper bound is equals to midpoint minus 1. If A midpoint equals X, exit, X is found in the location of the midpoint. End while loop. So this is a pseudocode written for binary search algorithm. Thank you. Thank you very much, students, for watching. Please do subscribe to my channel. Thank you.